Hello everyone, welcome back. In this tutorial, we are going to discuss more on top command. In last video, we have seen what are the different shortcut of top. Let's say example, if you run the top command on the screen and by default, this will show you here CPU or memory shorting. So to switch to memory, we generally press Control M, and again to back on CPU, we can press Shift P. So Shift M for memory and Shift P for CPU shorting. So let us understand more detail on top. So we'll run top command and just I will resize the screen again. Okay. So the first line is here, right? The top command and this detail. Excuse. So this one, the first line is very first is our current time. It's showing us the time. And the next line, it's showing us the up time. All right. So it's up from last 20 minutes and 16 seconds. Right. Next, it's showing us how many number of users is connected. Is 3 number of user is logged on the system. And it's showing us the load average. This load average, this 3 value is for 3 different time. One is for last minute, another is for last 5 minutes, and last one is for 15 minutes. So this we'll see later on how to calculate the load average and what is this load average means. The next part we can see the task, right? The first one, it's showing us the total number of running tasks. So as of now we have total is 109, and out of that 2 is running and rest 107 is sleeping. 0 is a stop, that is nothing is stopped on, and zombie is 0. So the zombie process is something that stopped, right? But this stopped and the stopped one is a different. Zombie means their parent is not there. That means that they are the process where no parent process is available for that, which we called as an orphan. So when the parent process is not available for any process, that become a zombie process. And the zombie process is a process, it unnecessarily use your resources, but that will not going to create any output or any sense for any users. So that zombie process need to be immediately killed, right? When it's happened in multiple time when the operating system not gracefully terminate that process are still live, but there is no sense to keep that process live. In that case, we can see that count if there is more than 0, I mean 1, 2, or any process is running in zombie category, we can go ahead and kill that. So that will help us to free your resources, or else it will consume your resources unnecessarily and we cannot get the resource for the right process. All right. Now let us move on the line number 3. CPU, yes. In the first one, that is 0.3 is the CPU utilization, but it's for only user processes, not for the system process. There is a 2 category of the CPU utilization. One is used for the user process, another is for the system process. All right. So here for us as of now is 0.3 utilization for the system. There is no load on the system, right? User have no work and system is using just negligible amount of CPU, right? Next one, CPU process with priority update, right? So any priority is updated from the default one is called as a nice one. So nice priority, any process consuming more CPU because its priority is updated. Like for example, by default, every process have some priority, right? But when user change that priority and it's consuming some amount of CPU to run that priority process, which is updated by the user, that will come here. Oh boss, I am using 88% of your CPU because you asked me to do this job on priority. But as of now, we have not set any job on the priority, so nice value is 0.0. Ideal, that's a good one. Ideal show us the real fact of the system, whether system is overutilized or it is underutilized. If it is overutilized, you can see that ideal value will be near to 0 or 10%. That means 90% of your system is used, right? If your ideal value is low, that means system is more used. If your ideal value is high, that means system is underused, right? Now it's showing around 100% system is ideal. There is no work on the system, right? So based on ideal value, we can immediately get the idea whether the system is utilized or not utilized. Next one is WA, is the CPU processes waiting for IO operations, right? Any processes is waiting for any IO operation. Maybe they are waiting for uh, input, that is maybe the some amount of keyboard enter, or maybe you want to write some file, but still the output device is busy. So in that case, it will go into the queue, and if there is any process is waiting in the queue and using my CPU, right? So there is no process waiting in the queue and using your CPU as of now. That's the reason we are getting 0.0. Next one is HI. HI is serving hardware interrupt. So hardware interrupt, any response we are getting from hardware to acknowledge that how much CPU I'm using, right? So as of now, no CPU I'm using to acknowledge my hardware interrupt. Same way the software interrupt, my application going to respond me back as acknowledgement. Is I'm using some amount of CPU to acknowledge that request? That is software interrupt. As of now, no, this is 0.0. The ST we call as a stolen memory. Stolen memory means, let's say example, on top of this system you have more 3 virtual machines running on it. Then how much amount of your CPU from your base machine used by the virtual machines? So that amount of percentage will come here. Let's say example, out of it 80% of your CPU stolen, that is used by the virtual machine, then it will show here. So this is very fantastic one, because if it is a hypervisor, this value become very critical for you to understand how much your CPU used for the guest operating systems, right? So as of now, no guest operating system is installed on this system. That's the reason we are seeing it 0.0. All right, let's move on the next part of the top command of memory section, which is not showing here. So we'll go here and we'll run it on the top. Still it's not showing, so let's get that some way. It's not showing the memory section. So it seems some issue in this file. So just I have reverted back. And now if we run the top command, it will provide all the details so that the file which we have edited, it's top RCA. That is very important. So we'll explain later on how to make permanent changes into top RC file. All right. So let us understand the line for the memory. So here, fourth and fifth line, that means this one. This two line is for memory. All right. So it's pretty simple to understand. It's showing the memory in KB, and here it's a free, it's a used, and it's a buffer and cache. For swap memory, it's showing this one is total, free, used, and available. All right. Now, let us understand what is swap memory. Swap memory, if your RAM is not enough to handle more requests, in that case, your swap memory gonna use. But if your RAM have enough memory space, then swap memory is not going to be used, right? So swap memory is basically the hard disk space is worked as a RAM, but it's not a replacement of RAM, right? So only case some jobs they bring from the RAM and go into the hard disk, that is swap memory, and again it go into the RAM. So we call as swap in, swap out. So program which out from swap, it's called as swap out and swap in, right? So what we are trying to see here is what is difference memory are available here, right? So here if you say the cache means if you are using that page again and again, or if you're using that program again and again, that is going to be saved in the cache. That data is going to be saved in cache, and that will be in a lesser time it gonna be presented to you, right? So presented means processing. So it will go to the processing more speed. It will not again retrieve from the hard disk and then go for processing. It will be in your buffer, in your cache, it will be located, and immediately when the request come, it will go for the process. All right. Now, which is available here, the memory which is available here, that is avail memory. All right. So that avail memory is pretty different from the buffer and cache. So it said that how much amount of memory available without swapping. So means if we not swap it, how much memory is still there. So if memory is very low, that means swapping is going to be happen. All right. So this is how we can check this. But of course, we are going to study this in more detail in our upcoming tutorials. Let's quickly go through this. The first one is called as a PID, that is process ID. The second column is denote the user. The third one is denote the priority. So we'll learn about the priority. Next one is denote the nice value. VIRT, it's denote the virtual memory used by the process. RES, it's denote the physical memory used for the processes. Next one, SHR, it's denote the shared memory between processes. It's the percentage of CPU, but before that, this one is a state, right? State can be a sleep, that is denoted by the capital S. It can be a running, it's denoted by capital R, or it can be a zombie, which is denoted by the, again, Z, or it can be a other symbol, but it will not running and sleeping. Memory. percentage of memory, and how long this process is running is the time, and the complete command of that process. Thank you for watching it.